Okay, number 25 on page 513, we're supposed to find 4 geometric means between 1 and 2. So those are going to be little values. So let's look at this. Let's make a sequence, a geometric sequence, where the first term is 1, and then I'm going to put 4 means between those two values, 1 and 2. So 1, 2, 3, 4 means, and then 2. So these are, everything in here are going to be values between 1 and 2, and when we multiply 1 by something, we'll get this value, and we multiply that by the common ratio to get this, and so on and so on, and we have to end exactly on 2. So first term, second, third, fourth, fifth, this would be the 6th term in a little list. So I'm going to use the fact that any term in a geometric sequence can be found by taking the first term and multiplying it by the common ratio n minus 1 times. So if I just look at the 6th term, if I take the first term, I have to multiply it by the common ratio 5 times. Okay, 1, 2, 3, 4, 5. So let's look at, we've got the values. The 6th term is 2, and the first term is 1, and that gets multiplied by r to the 5th. And this allows us to solve for the common ratio. So 2 is r to the 5th. So if I raise both sides to the 1/5 power, I get that the common ratio is 2 to the 1/5. And I'm going to keep those in exponential form for now, because they're really easy then to multiply with. So if I take 1 now, and I multiply it by the common ratio of 2 to the 1/5 power, I get 2 to the 1/5. Now, when I take 2 to the 1/5 and multiply it by another 2 to the 1/5, I get 2 to the, because I'm multiplying powers with the same base, so I add those exponents, so I get 2 to the 2/5. Now, when I take 2 to the 2/5 and multiply it by 2 to the 1/5, I get 2 to the 3/5. And so on. You can probably see the pattern. So this would be 2 to the 4/5, and then when you finally multiply that, 2 to the 4/5 by 2 to the 1/5, we get 2 to the 5/5, which is 2 to the 1, or 2. So we end up okay. Now the way that your book shows this 2 to the 1/5 is they show this as the 5th root of 2. And the way they show 2 to the 2/5 is they take the 5th root of 2 to the 2nd power, so the 5th root of 4. And they show 2 to the 3/5 as the 5th root of 2 to the 3rd power. And so they simplify that to 8, and this is the 5th root of, so the 5th root of 2 to the 4th, or 16. Just understand their equivalent, and it's probably easier to think about using exponential form. And that is it.